Who here has ever noticed piles of salt on the roads in the wintertime? Maybe at an intersection, on a sidewalk, or perhaps on campus. I know I certainly have. Road salt, or sodium chloride, is a commonly used de-icing agent used to melt ice and snow by lowering the freezing point of water. Each year, around 20 million metric tons of road salt are applied to prevent vehicular accidents and slipping and falling. Salt is crucial to our safety in the winter months, but do we ever stop and think about where it goes after it's applied? Salt deposited on roadside areas can travel through soils and make its way into the groundwater, leading to the presence of sodium and chloride in streams year-round. Salt can also travel via meltwater into nearby storm drains, which discharge directly into nearby waterways. These elevated levels of salt in streams can have critical impacts on aquatic ecosystems and drinking water. Philadelphia is especially vulnerable to this issue, as many municipalities utilize surface waters for their drinking water supply. My study set out to determine the impact of road salt pollution on 7 local watersheds in southeastern Pennsylvania. I sampled these 7 sites weekly for a year to monitor for seasonal changes and to determine the impact of paved surfaces, like parking lots and driveways, on water quality. All sites, regardless of time of year, exceeded the EPA recommendation for sodium in drinking water for individuals on a reduced sodium diet. This could potentially be dangerous, especially in the winter when the values were the highest, and could increase our risk of developing hypertension. Additionally, samples from all sites crossed the EPA threshold for chloride, indicative of negative impacts to aquatic organisms. Unsurprisingly, the greatest number of exceedances occurred during the winter months when we experienced the most snow. We also conducted high-frequency chloride monitoring for one of my sites. This stream is visited by Villanova Intro to Environmental Science students each year and has been historically poor in macroinvertebrate diversity, an indicator of poor stream health. Over the past year, this stream exceeded EPA guidelines for chloride 4 times the recommended duration for long-term exposure, and these consistently elevated levels of chloride pose an increased risk to aquatic life and human health. My study results suggest the clear need to limit our road salt application to protect our aquatic ecosystems and drinking water supply. The results will be used as a benchmark to test the effectiveness of remedial actions by local municipalities, such as the adoption of roadway brine, a diluted salt mixture. It will also help public education efforts aimed at the household level on reducing salt pollution to our waterways. This is especially important as the #1 way to reduce road salt pollution is to use less salt, and as the image behind me shows, a little can go a long way. Thank you.